This bite-sized learning is the first of a series of videos looking at building a bot based on a Raspberry Pi. Even if you don't want to build the bot, the content of the video series will help you with topics such as configuring sound on the Raspberry Pi to enable recording from a microphone and playing audio files, driving chainable RGB LEDs and controlling servos, capturing images from the Raspberry Pi camera, and getting input from the SenseHAT and controlling the LED matrix on the SenseHAT. There'll be minimal coding, as I'll be using Node-RED running on the Raspberry Pi to create the applications to control the bot. And I'll also show you how to create a dashboard using Node-RED. To bring the bot to life, I'll show you how to use cloud services to add speech to text, text to speech, video recognition, access to weather data, integrating social media such as Twitter, and enable the bot to hold a conversation. The bot is based on the TJBot project, but I've added a SenseHAT to the front, and all my programming is in Node-RED. I call my bot Toby Jnr. If you want to stick to the original TJBot design and leave off the SenseHAT, then you can still follow along, but won't be able to access the features enabled by the SenseHAT, such as joystick control of the bot, access to environmental data, or LED panel output. There are kits you can buy with all the parts, or if you head over to the Git repository, you can get the files needed to laser cut or 3D print your own TJBot. To mount the SenseHAT, you'll need to create a hole in the front of the head to allow the SenseHAT connector to go through. You may want to add the hole to the laser template or 3D print files before you cut or print the head of the bot. I've added the 3D printer file I created to my Git repository. In addition to the body, you'll also need some additional components. You'll need a Raspberry Pi 3B. This is the version of Pi that the laser cut and 3D files are designed to accommodate. You'll need a Pi camera, a micro servo such as the Tower Pro SG90 or 92, a mini USB microphone, Bluetooth or USB speaker, and you can't use the 3.5mm socket on the Pi, so you'll need to use a USB or a Bluetooth speaker, and I'll discuss this more on the video on sound. If you're using a Bluetooth speaker, you'll also need a Bluetooth dongle, because the internal Bluetooth connection doesn't provide a reliable connection for sound. You'll need a NeoPixel diffused 8mm through-hole RGB LED. There are other chainable LEDs available, and I'll discuss these in the video on driving the LED and servo. Optionally, you need a SenseHAT. You also need an 8 or a 16 gigabit micro SD card and a power supply for the Raspberry Pi. I would recommend setting up the Raspberry Pi before installing it into the body and wiring it up, as you may need to connect a USB keyboard, mouse and monitor cable, which is easier before it's installed in the body. Once the Pi is set up, all access is going to be over the network.